Okay, this is number 3. If 3x squared minus 2x plus 7 is equal to 0, what's x minus 1 over 3 squared? So this is probably one of the harder problems, probably the hardest one in the whole thing, considering it took me a while to solve it. Maybe to some it might be a little bit easier, but to me, maybe I overcomplicated in my solution, but it was pretty difficult for me. So I will try to explain it as best as I can. It's okay, Millie, if you can't solve this one. It's pretty hard. So the first thing that I tried to do was I tried to use the AC method for this one, factoring, 3 times 7, 21, the factors of 21 that when you add give you -2. I found that there is none. Second, I used the quadratic equation, which is minus b plus or minus square root of b squared minus 4ac. But I found out, minus 4ac over 2a, and I found that none of that would work, so I decided this is not the way to go. So then what I tried to do next is direct comparison. So what I did is I expanded this part, because they're telling me that this is equal to 0, but what is this equal to? So I didn't know. So the first thing I did is I assigned this mystery value instead of a question mark. I assigned it capital Y, sorry. Don't know my alphabet. So then what I did is direct comparison. So I wrote down this equation on top, 3x squared minus 2x plus 7 is equal to 0. Then what I did is I got this factored portion and I expanded it again. So I wrote down x minus 1 over 3 and then x minus 1 over 3. And what I did is I used the distributive property or FOIL, whatever you want to call it. And then the first term, first out, inner, last. So x times x is x squared. X times minus 1/3 is minus 1/3 x. Minus 1/3 x again. And minus 1 over 3 times minus 1 over 3 is plus 1 over 9, right? It's multiplication of fractions. I'm doing this pretty fast because, I would assume that you guys know this by now. So the next thing is to combine these like fractions. They're both with an exponent of 1, so I can combine them and say that this is x squared minus 2 over 3x plus 1 over 9. Sorry, I said 1 over. Plus 1 over 9. So then I figured that when I expanded this, I got this quadratic formula. And then having both of these together rang a bell, because look, watch what happens when I write it down right on the x squared minus 2 over 3x plus 1 over 9 is equal to y. And y is the thing that I assigned to the value that I'm looking for. Yet again, like I'm saying, this problem is pretty hard. So, and then what I did next is I compared these two quadratics and saw what they had in similarity. If you notice, if you multiply everything here by 3, it holds a very close relationship to the equation above, because 3 times x squared is 3x squared. 3 times 2 over 3x is minus 2 over x. And you can do that by yourself to prove it. I expect you to know it by now. But the only thing that's missing though is when you multiply 1 over 9 times 3, you're not going to get 7, which right there rang a bell that I have to use. I'll show you the equation. I'll shut up right now. But the important thing to realize is that, of course, you're multiplying this side by 3, but technically you still have to multiply the value you assigned by 3 as well, because what you do to one side you have to do to the other. So let's multiply this whole row by 3. So we're gonna get 3x squared, right? And now 3 times 2 divided by 3, that's just, let me write it better, minus 2x. And now 1 over 9 times 3, well, it's going to take the numerator spot, 3 over 9. Well, 3 over 9 can be simplified to what? Well, 1 over 3. Alright, 1 over 3. So again, this is a long problem. And the next thing now that I try, I forgot it. So I multiplied this, so I have to multiply my assigned value that I'm looking for, capital Y. I have to multiply that one by 3 as well. So the next thing is now I'm trying to make this bottom part look exactly like this top part. So what is this 1/3 missing to get to 7? Well, 6 2/3, because 6 2/3 plus 1/3 is going to get me to the 7. So what I did is I added 6 2/3 to this side, so I have to add it to this side too. So 6 2/3 to this side as well. So when I do that, this right here becomes 7. So let me see, let me get some space. And so now this whole part becomes 3x squared minus 2x plus 7 equals the 3y, 3 capital Y, plus the 6 2/3 that we initially, that we just added to both sides to make it 7. Now if you notice, now we have the same exact thing that we have in the top. And they're saying that 3x squared minus 2x plus 7 is equal to 0, which means that this right here can all be substituted in with a big 0. And 0 is equal to 3y plus, now if we notice this 6 2/3, it's a proper fraction. It's easier to deal with impropers at this point, so we're going to turn it to an improper. 6 times 3 is 18, 18 plus 2 is 20, and it's 20/3, right? But remember that we're trying to solve for capital Y right here, right? So what we do next is it's simple. Now it's just a simple problem. 0 is equal to 3y plus 20/3. Well, we're going to subtract 20/3 from both sides, minus 20/3, and then we get minus 20/3 is equal to 3/y, right? Now, maybe at this point you might not know how to subtract, how to divide, so I'll just show you. We're going to divide this by 3 to isolate the y. So we're going to have minus 20/3 divided by 3. So let's write this right here just in case you're confused. Minus 20/3 divided by 3, right? Well, in a way, there's no such thing as division, so it all turns basically down to multiplication. But this 3 is not a simple 3. It's also a 3/1. So what we're going to do is we're going to multiply this numerator by the reciprocal of the denominator, which turns it into a multiplication operation for the fractions. So 1/3, negative 20 times 1 is minus 20. 3 times 3 is 9. So at the end, we figure out that this is our y, or this is the value for x minus 1/3 squared. So this is our answer, minus 20/9. Pretty hard problem.